Hello, my name is Nick Deborah, and in this short video, I want to talk about how to handle outliers in our charts. What exactly is an outlier? Well, it might be a situation like this, where we're showing the land areas of the 10 largest countries in Europe, and we can see that Russia, for example, is just much larger than the other countries. And so that's an outlier, right? It's a value that is much greater than the other values in a chart. Sometimes you can have several outliers, in fact. A lot of people will immediately assume that this chart is kind of broken, it's not working properly because I can't really see the other values clearly. However, you always want to come back to sort of the job of the chart. What is the purpose of this chart? If, for example, is to show that Russia is simply much larger than other European countries, then this chart is not broken, right? It does not need to be fixed because that's exactly what it says. However, if the main insight that we're trying to communicate, the job of the chart, is to show that Ukraine, for example, is twice the size of Poland, okay, well, obviously it's going to be hard to compare any of these to one another. And so in this case, maybe this chart isn't working very well. There are a couple of common approaches that people use when they need to show basically the smaller values in a chart with outliers. One of them is to simply just exclude the outlier or outliers. So here we're showing all the countries excluding Russia, excluding the outlier. And so this does make it much easier to see and compare the smaller values, but it's also kind of easy for people to sort of forget that there is an outlier, and they can't really see just how much smaller the smaller values are than the outlier. And so in my view, this is not really a great solution. Another common sort of approach here is to do what's called breaking the quantitative scale. And so here you can see that I've broken the axis so that the scale goes, 200,000, 400,000, 600,000, and then up to 17 million, because that's about where Russia is. And even though this is kind of a common approach, I also don't really use it because, well, for a couple of reasons. The first is that really when you think about it, what does this break actually mean? Well, really what it means is this bar length is wrong, right? You cannot compare it with the others. It looks like, for example, Russia is maybe 50% larger than Ukraine, but that's not even close to true. It's something like 50 times larger than Ukraine. And so, especially in a bar chart, that doesn't really make sense because the whole point of a bar chart is to allow us to compare the values using bar length, right? But I can't do that when I break the scale. It also kind of assumes that readers are going to, first of all, notice this and also understand what it means. And that can vary a lot from one audience to the next. And so for these reasons, I generally don't use this approach either. For those who have more of a kind of mathematical background, they might be thinking, well, it's simple. We can just use what's called a logarithmic or a log scale. And so here we've changed the quantitative scale so that it doesn't go up in jumps of 100,000 or a million. It jumps up in powers of in this case, 100, right? So 1, 100, 10,000, a million, 100 million. And so one of the effects, of course, of this is that it does make our smaller bars taller, right? And so in theory, this makes them easier to see, easier to compare. However, in practice, people struggle to read values on logarithmic scales. For example, if I were to ask you, okay, what is the value for Russia? How many square kilometers is Russia? 15? 50 million, right? And even people who work with logarithmic scales often find that it's quite difficult to compare values with them. And you can end up with weird effects. Like, for example, it looks like all these countries had almost the same land areas, but they really didn't. They're actually quite different. And so again, a couple of reasons why I actually wouldn't use a solution like this. What do I do in situations where I have an outlier or outliers in my chart? Well, I'll start with kind of a zero baseline chart, right? Where I start the chart at 0 and just a regular kind of linear scale. But then I'll add what's called an inset chart. And so this kind of gives me the best of both worlds, right? I can see the outlier, right? I'm not hiding it, it's right there. And I can see just how much larger it is than the other values here. But I can also very precisely compare these smaller values with one another. And so this is kind of my go-to solution with outliers, right? Now, there are some kind of subtle design aspects to this which make it kind of work, I think, fairly well. For example, the bars in this kind of big picture chart here line up perfectly with the bars in the zoomed in chart. This kind of depends on the chart type. If it's like a stacked bar chart or something, you can't really do this, but in many cases you can line up the elements in the big picture chart with the zoomed in chart, which is a good thing to do. This kind of gradient color effect here shows that this bar kind of continues, kind of off of the zoomed in part. No category names here to show that these are basically the same categories as these, right? To help people understand, oh, right, same categories, clarifies the relationship here. And even the drop shadow here kind of suggests that the zoomed in chart sort of pops out of the big picture chart, again, helping to establish the relationship between the two charts here. Unfortunately, if your chart will be dynamically generated on, say, a live data dashboard in something like Power BI or Tableau or Click or something like that, unfortunately, most of these features are not really available in products like that. And so you're going to have to fall back on something like this, where you don't have any boxes or drop shadows or anything, and rely on labeling like all countries, all countries except outliers. And so maybe not as visually intuitive as when you're creating a chart for a slide, for example, or a report where you can pretty much do whatever you want, but it still kind of works. The nice thing about this inset chart approach as well is that it works for pretty much any chart type, right? We can use this for line charts and scatter plots and just about anything else. So far I've talked about using inset charts to handle outliers, but there's actually another really common situation where inset charts can be really useful. And I created a whole separate video about that, which I'll link at the end of this one. If you want more tips like these, I will be teaching my Practical Charts course, which contains this tip and many others, kicking off on June 2nd, 2025. And so if you happen to be watching this video before then, you can get information about that workshop at my website, practicalreporting.com. To learn about the other common use case for inset charts, just click on the video right here, and you can learn about that as well. Thanks very much for watching. I'm still waiting. Why haven't you clicked on it? It's a great video. You should watch it.